OpenSSL is a renowned software library utilized by applications to ensure secure communications across computer networks, safeguarding against eavesdropping and verifying the identity of the endpoint. Commonly employed by Internet servers, including the vast majority of HTTPS websites, OpenSSL integrates an open-source implementation of the SSL and TLS protocols. The central library, developed in the C programming language, encompasses fundamental cryptographic functions and various utility features. Diverse wrappers enable the integration of the OpenSSL library across a range of computer languages. The OpenSSL Software Foundation, OSF, oversees legal aspects of the OpenSSL project, such as contributor license agreements and donation management. Additionally, OpenSSL Software Services, OSS, manages support contracts for the OpenSSL project. Operating on various Unix-like systems, including Linux, Mac OS, and BSD, Microsoft Windows, and OpenVMS, OpenSSL traces its origins back to 1998 when it was established to furnish a set of encryption tools for Internet code. Stemming from a fork of SSLA by Eric Andrew Young and Tim Hudson, the OpenSSL project took root following the discontinuation of SSLA's development when both Young and Hudson joined RSA Security in December 1998. OpenSSL offers a variety of cryptographic algorithms for encryption, hashing, and public key cryptography. It includes ciphers such as AES, Blowfish, and DES, cryptographic hash functions like MD5 and SHA, and public key cryptography algorithms such as RSA and Diffie-Hellman key exchange. The software also supports FEPS 140 validation, a U.S. federal program for certifying cryptographic modules. OpenSSL faced controversy when it designated the 1.0.2 version as end-of-life despite being the only version with FIPS mode support. This decision led to compliance issues for users who could not transition to the newer FM 2.0. OpenSSL eventually introduced version 3.0 to restore FIPS mode and underwent FIPS 140 and 2 testing, which faced delays but eventually achieved certifications following engagements with testing labs. OpenSSL had a dual licensing system under the OpenSSL license and the SSLE license, allowing the use of terms from either license. The OpenSSL license was similar to the Apache License 1.0, while the SSLA license shared similarities with the 4-clause BSD license. However, due to its Apache License 1.0 roots, it mandated the inclusion of a specific phrase in advertising material and any redistributions, making it incompatible with the GNU GPL. To address this issue, some GPL developers included an OpenSSL exception in their licenses, permitting the use of OpenSSL in conjunction with their systems. Packages like GNU wget and Clim employed such exceptions, while others like Deluge chose to modify the GPL license to accommodate the OpenSSL usage. Alternatively, some packages opted for different libraries such as LGPL-licensed GNU TLS, BSD-licensed Botan, or MPL-licensed NSS to fulfill the same purpose. In August 2015, OpenSSL announced a significant change, requiring most contributors to sign a Contributor License Agreement, CLA, with a plan to relicense under the Apache License 2.0. This transition began in March 2017 and was successfully completed by 2018. By September 7, 2021, OpenSSL 3.0.0 was unveiled under the Apache License 2.0. Throughout its development, OpenSSL encountered several notable vulnerabilities. These included issues such as denial of service, DOS, due to ASN.1 parsing, the OCSP stapling vulnerability, and the ASN.1 bio vulnerability. Furthermore, weaknesses like the SSL, TLS, and DTLS plaintext recovery attack, predictable private keys due to a Debian-specific issue, the infamous Heartbleed bug exposing sensitive data, and the CCS injection vulnerability were also identified. Agglomerated SSL was created in 2009 by Marco Peerboom, an OpenBSD developer, as a fork of the original OpenSSL API to address frustrations with its complexity. This new project, also known as ASSL, utilized the OpenSSL API internally while providing a more straightforward external interface. However, it was later deprecated in favor of LibreSSL, which emerged in response to the Heartbleed vulnerability in April 2014. In the early stages of LibreSSL, over 90,000 lines of code were removed from the OpenSSL branch, showcasing a significant effort towards streamlining the codebase for improved security. Following suit, Google introduced its fork of OpenSSL called BoringSSL in June 2014, aiming to collaborate with the developers of OpenSSL and LibreSSL. The development of BoringSSL led to the creation of Tink, a novel library based on BoringSSL. In a collaborative effort between Akamai and Microsoft, QuickTLS emerged as a fork based on the OpenSSL 3.3 release, integrating features and fixes from the current OpenSSL repository. This initiative aimed to enhance the TLS capabilities required for supporting the third version of the HTTP protocol, emphasizing the need for adaptations within TLS libraries. Despite initial efforts to propose these modifications to OpenSSL, the project faced delays and uncertainties, leading to the eventual creation of the QuickTLS fork by a volunteer team from Akamai and Microsoft. This decision was well received within the community, paving the way for continued development and support of the necessary patches. While OpenSSL 3.0 was eventually released, the decision not to adopt the quick patch set evoked disappointment within the user community. The closure of the pull request prompted public expressions of dismay and calls for alternative solutions, highlighting the challenges faced in aligning with evolving user requirements. As of February 25, 2023, a long-term supported TLS library, compatible with Quick, remained unavailable by default in operating systems, underscoring the ongoing need for collaborative efforts and innovative solutions within the realm of cryptographic libraries.